Our universe is incredibly vast and mysterious. But have you ever wondered where it all began? Scientists believe that our universe started from a single point. This point, smaller than you can imagine, suddenly expanded outward. We call this event the Big Bang. The Big Bang theory is the leading explanation for how our universe came to be. It suggests that about 13.8 billion years ago, everything we know was concentrated into an extremely small and dense point. Imagine all the stars, planets, and galaxies squeezed into something tinier than a grain of sand. From this tiny point, the universe expanded rapidly outward. It wasn't an explosion in the traditional sense, like a firework. Instead, it was the fabric of space itself stretching and expanding in all directions. This expansion continues to this day. Think of it like baking a loaf of raisin bread. As the dough rises, the raisins within it move farther apart. Similarly, as the universe expands, the galaxies within it move away from each other. The Big Bang is a fascinating concept that helps us understand the origins of everything we see around us. Before the Big Bang, our universe existed as a singularity. Picture the smallest thing you can possibly imagine, then shrink it down trillions of times. That's how tiny the singularity was. Now, this wasn't just any tiny point. It contained all the matter and energy that would eventually become everything we see today. Stars, planets, galaxies, even you and me. This incredible density created an environment of extreme heat and pressure. It's hard to wrap our minds around the concept of a singularity. Our everyday experiences don't really prepare us for understanding something so small and yet so massive. But that's the beauty of science. It allows us to explore concepts beyond our immediate grasp. The singularity represents the ultimate mystery of the universe. It's a reminder that there's still so much we don't know about the cosmos and our place within it. Suddenly, the singularity began to expand rapidly. Space itself stretched outward, carrying all the matter and energy along with it. This expansion was incredibly fast and powerful, marking the beginning of our universe and everything in it. In the first fractions of a second, the universe was an incredibly hot and dense soup of particles. As it expanded and cooled, these particles began to combine, forming the building blocks of atoms, protons, neutrons, and electrons. This early universe was a chaotic and energetic place, but it was also the crucible where the fundamental forces of nature as we know them began to take shape. Gravity, electromagnetism, and the strong and weak nuclear forces all originated from this primordial soup. The Big Bang wasn't just an explosion of matter and energy, it was the birth of physics itself. As the universe continued to expand and cool, these forces shaped the cosmos into the wondrous structures we observe today. Section 4. Expanding Horizons. Our universe is always growing. The expansion that began with the Big Bang didn't stop. In fact, the universe is still expanding today. It's like an inflating balloon, with galaxies moving farther apart as the space between them stretches. We know this because astronomers have observed that distant galaxies are moving away from us, and the farther away a galaxy is, the faster it appears to be moving away. This observation supports the idea of an expanding universe. The expansion of the universe is a mind-boggling concept. It means that the space between galaxies is constantly increasing, and the universe is becoming less dense over time. But don't worry, this expansion doesn't affect us on Earth or even within our galaxy. The gravitational forces within our solar system and galaxy are strong enough to keep everything together. The expanding universe is a testament to the incredible power of the Big Bang and the dynamic nature of the cosmos. Section 5. Echoes of the Big Bang unlocking the secrets of the universe. Scientists have found evidence to support the Big Bang theory. One of the most important pieces of evidence is something called the cosmic microwave background radiation. Think of it as the afterglow of the Big Bang. It's a faint signal of light and heat that permeates all of space. This radiation was emitted just a few 100,000 years after the Big Bang, when the universe had cooled enough for atoms to form. By studying this cosmic background radiation, scientists can learn about the conditions in the early universe. It's like looking back in time to the universe's infancy. The cosmic microwave background radiation provides strong evidence for the Big Bang theory. It's a faint but persistent reminder of our universe's explosive beginnings. Section 6. A Universe of Wonder, Our Journey of Cosmic Discovery. The Big Bang theory is a remarkable achievement of modern science. It helps us understand where our universe came from, how it evolved, and where it might be headed in the future. But it also reminds us of how much we still don't know. What caused the Big Bang? What, if anything, existed before it? These are some of the biggest questions in science, and they continue to inspire astronomers and physicists today. As we continue to explore the universe and unravel its mysteries, we gain a deeper appreciation for the wonders of the cosmos and our place within it. The Big Bang Theory is not just a scientific explanation, it's an invitation to explore, to question, and to marvel at the vastness and complexity of our universe. So the next time you look up at the night sky, remember the Big Bang, the incredible event that set our universe in motion and continues to shape the cosmos we see today.